Hey guys, welcome to a new video. Today we are going to talk about building complex features using test-driven development, or how I like to say test-driving complex features. Before we begin this lesson, I'm going to ask you to like this video, subscribe to the channel, and follow me on Twitter. That really helps. But anyway, let's jump right into it. Actually, one second. I have several lessons on test-driven development on my channel. I have a course, and there are numerous resources on test-driven development throughout YouTube, blog posts, Twitter. But it's really hard to show you guys something that's complex in a 15-minute or 30-minute video. On this lesson, I'm not going to cover the basics. I'm not going to cover how to set up your test environment, how to write your first test. I have videos for this. They are free. They're on the channel. I'm going to link them in the description. But this is more of an intermediate level video. So it's for someone who is still already testing their code. It's just starting out. You don't have to be super experienced, but some experience is needed. If you're just starting out, you might not really understand what's going on. So I wouldn't suggest this particular video. We're also going to use Pest, which is another test framework similar to PHP Unit. It actually runs on top of PHP Unit. It was created by Nuno Material from Laravel. It's not that much different from PHP Unit. If you've ever written a test using PHP Unit, you are going to totally understand what's going on in Pest, but the syntax is a little bit different. The way you write tests is a little bit different. So if you're not familiar with Pest, I suggest you take a look at their documentation. That way you can understand what's going on in this lesson. But anyway, let's jump right into the screencast. So see you soon. Okay guys, so I have this little project that I'm building on my free time, and it deals with money, not only cash, but also crypto and stocks. And it's basically a way for you to add all of your investments, be it crypto, stocks, cash, whatever you have, in a single application, so you can see your total net worth, how much you're making in profits every month, how much you're spending on your bank account. You have separate accounts, but the point is, you have cash, you have crypto, and you have stocks. So if I go back here and we take a quick look at the models, you're going to notice we have an account, we have currencies, we have prices. Don't forget about this one for now. But we have the important ones are assets, accounts, and transactions. So you can see that an account can have transactions, right? And you can add a transaction using a transactionable. An account belongs to currency, it belongs to a team, and it has many transactions. So if you go into the transaction model, you can then see it belongs to an asset. And that's where things get interesting. So imagine the following scenario. You have your stock account and you just bought 10 shares of Apple at $30. By the time you bought this, it was worth $30 each share. And then 3 months later, you bought another 10 Apple at $40. Okay, cool. So what is your total invested here right now? Well, it's obviously 10 times 30 plus 10 times 40, which equals 700. So you have $700 invested in Apple. That's cool. That's your total. That's how much you've paid for your stocks. But right now, Apple costs $50, right? So you don't have $700 invested. You actually have 20 times 50, which means you have $1,000 invested in Apple. 20 means the amount of shares you have, and 50 is the current price. So things are a little bit harder to work with in code than they seem. If we think about it, you have total invested, position, your current position in Apple, you have a $300 profit, and you have 20 shares. So that's your position. Now, why do we need to build something that allows us to see this? Because we want to show users how much they have in each of their positions. So we have transactions, right? So if I have 100 shares of Apple, it doesn't mean that I bought all of them at the same time for the same price. I could have made 10 transactions, 20 transactions. I could have, maybe I bought it sometimes, then I sold it. I don't know. That's the thing. That's why it's a little bit hard to figure this out. And I don't know how to build this. I have no idea how to build this. What I'm going to do is I'm going to write some tests first with how I would like this to work. So instead of writing, the path, I'm just going to figure out a destination and then figure out the path. What do I mean with this? So the first thing I'm going to do is I'm pretty sure we need a position class. I'm going to put it on the app namespace. Okay, namespace app, class position. And it's just going to be an empty class. Then I'm going to generate a test for this class. So artisan pest, let me write the full command. And I'm going to say position test. Okay, position test was created. So let me delete this. I'm going to say uses refresh database because I want the migrations to run on this task. And now this is where I'm going to start thinking about what I want to do with this class. What do I want to see on this object? What do I need from this object? So we need the user's average price on a given asset. We need the total shares or, units of a given asset. We need the total spent on the asset. And we need the total position on an asset. We also want the profit. So that's basically what we want. So what I'm going to do is I'm going to write a scenario where a user bought a stock or crypto multiple times. And I'm going to use predefined inputs and make sure I get what I expect. So let's think about this. What I'm going to do is I'm going to write a test. So test. And we can say it fetches a crypto position. And then let's write the test. So the first thing I'm going to need is an account. So I'm going to say account. This is a helper. It just returns an account factory, creates an account for us. The reason I do this, this was a tip given to me by Samuel Stancil from Lean and Laravel multi-tenancy. We can type hinted. So when I say account, my editor can figure out that I'm talking about an account model. So I also need an asset. I'm going to be working with crypto, right? So I need to have an asset. Let's create one. So we can say Bitcoin, and we can say asset factory create. There are a few properties that I haven't talked about, but they're not really important. Basically, the type. Those are not really relevant for what we're doing. So the asset type is crypto. The code is BTC. And the current price is going to be 40,000. We're a couple months behind. Actually, we don't need those. So if I do a dump and die here and I execute this test, okay, we can see the asset right here. The name is obviously not that one, so let's write this one down as well. Bitcoin. And okay, cool. Now we have a proper object. So we have Bitcoin to work with, not a single Bitcoin or a quantity of Bitcoins, but the asset. And I'm going to add some transactions to this account. So I'm going to say account, add transaction. And the transactionable is going to be a crypto transaction. So here's a good thing of working with objects. I can clearly see what I need to pass. This is a little bit tricky. I use amount and quantity and then an asset as the arguments. This verbiage might not be the best, but we're going to use it for now. So amount should actually be price. For now, let's call it amount. You know what? I'm going to change this. No, I'm not going to change it. We're going to keep calling it amount. But understand that this is the price. So I bought some Bitcoin for, let's say, $20,000, and I bought a single Bitcoin. And here's the asset. Okay. Then I went and I said, okay, I need more Bitcoins. And I bought some more Bitcoin, but now it was a tad more expensive. I bought it at 35,000, and I also bought two Bitcoins at this price. So let's add some comments. I spent 70,000 bucks for two Bitcoins, meaning per Bitcoin. And here I spent 20,000 for one Bitcoin, meaning $20,000 per Bitcoin. Okay, so we have some transactions. Now we need to fetch a position. And how am I going to do this? I don't know. So I'm going to say position, and I'm going to say position make, and I'm going to pass an account and the asset, because I want the position of the asset for the account. Does that make sense? So I want to fetch the Bitcoin position for a given account. So let's say this position make, and then I'm going to make a series of expectations. So I'm going to use past higher order expectations, and I'm going to expect the position. So this is the where we're starting at. And I'm going to say that I expect the average price to be, so let's calculate the average price here. It would be 90,000, so to 20,000 plus, so 90,000 divided by 3. So the average price is $30,000. I expect it to be a float. This is important. So if I were to use to equal, I could just write this and the test would pass. But if I use to be, I need to write down exactly what I wanted. In this case, I want a float, because in this case, it's not, but you could have a fraction, you could have cents. So I expect the average price to be 30,000 bucks. I expect the quantity to be 3, a float again. And the reason is you can buy half a Bitcoin, you can buy 0.14 Bitcoin, you have fractions. So I want to make sure we're dealing with those. I want to make sure I'm receiving a float. Well, the total spent needs to be 90,000 bucks. That's all I spent on those Bitcoins. I must be rich by now, because it's what, 60,000 bucks? Sadly, I'm not, so I need you guys to buy my course. Anyway, I also expect the total position. This might not be the best name, but I want the total position to be, how much is it worth now? 40,000, and I have 3 Bitcoins. So it has to be $120,000, because I have 3 Bitcoins and each Bitcoin costs 40,000. So here's what I'm going to do to make sure this is more understandable. I'm going to add some variables. So the average price is going to be 3. It's actually be quantity of Bitcoins. Sorry, I'm the worst person at math. So the total spent divided by the quantity of Bitcoin. So total spent is going to be 35,000 plus 20,000, 90,000. The average price is going to be the total spent divided by the quantity of Bitcoins. So let's change this for total spent, and let's change the quantity for quantity of Bitcoins. And we don't have this variable yet, so quantity of Bitcoins equals 3. We have the total spent, we have the average price, and then we got to figure out the total position. So the total position is going to be the quantity of Bitcoins times Bitcoin's current price. Okay, cool. So let's add this here, total position. Okay, what's the profit? So the total profit is going to be the total position minus the total spend. And note that sometimes this could be negative. So let's say total profit to be total profit. Okay, cool. Let's see what else we have. I think that's pretty much it. Oh no, there's one more thing I want to make sure. So I'm going to say and I don't need to do this, but just for clarity, I'm going to say that the, let's do it like this. So you can say asset is Bitcoin to be true. Okay, so what am I doing here? Let's go line by line. I'm passing an object to expect here. This is a higher order expectation. That means for each line of this, it's going to make an assertion on the value you passed here. And Bass is clever enough to know when you called an expectation method. So I'm just calling average price here, but I could call a bunch of stuff and then call to be, and Bass is smart enough to understand that the last result from this chain is the one that the expectation should run on. This one is an example. We're going to get to it right away. So average price, this is what we want to perform an assertion on. We want it to be average price. Quantity, we want to be the quantity of Bitcoins total spent. And here you can see that here's where the Bass magic happens. And this is so clever. I think I looked down and wrote this, and it's just amazing. So we're saying that the asset, we're now accessing the asset property. And then we're calling a method on asset, and then we're calling an expectation. So when Bass is proxying these calls, it figures out that, okay, we just got a call for a method that Bass has. So we should wrap up this and run the expectation, run the assertion. And then it goes back to the normal chain. So we're accessing asset, which is an eloquent model. And then we're calling the is method. If you're not familiar with the is method, this is a method provided by Eloquent to compare two objects to make sure they refer to the same record on the database. This is what I'm doing. I'm making sure that the asset for this position is the Bitcoin I expected. And I can even go further and say that the account is the account as well, to be true. Okay, cool. So we have this test, but it's not going to pass. Let's run it. So it failed. Call to undefined method position make. So let's write this down. I'm going to use this PHP 8 feature, which I forgot the name. I think it's property promotion or constructor promotion, something like that. So I'm going to say that we're going to expect an account. Let's import it. And we're also going to expect an asset. Let's get rid of this. Okay. So we have the constructor. Now we need to add the static method make. Let's do it. So it expects an account and it expects an asset as well, and return self. So we're going to say new static. If you don't know what I'm doing, this is just a fancy way to instantiate this class. And the reason I'm doing this is because I wasn't sure what I was going to need exactly on the constructor when I wrote the task. So I created this little make helper. Non-static method should not be called static. Okay, cool. So now we should at least get this passing. It returns a new position. So let's try running this. So call to undefined method average price. Let's implement this method. I'm going to leave this method down below. So average price, it's going to return a float. So here's where things get tricky. How do we implement this? We only have an account and an asset. Well, we're going to need the transactions. We have two transactions in this test scenario, and we need them to make these calculations. So I can already see that we need another property here. So let's call it, it's going to be a collection. For now, it can be just a standard collection called transactions. And we need to fetch those transactions. So you can say on the constructor, we can say transactions, this get transactions. Let's write this down. Get transactions, which returns a collection. So the first thing we need to do is we need to make sure we can fetch those transactions. So I'm actually going to do something different. I'm going to add a couple more assertions here. I'm going to say expect position transactions. And we're going to say I want the first transaction here. I want to make sure the first one is, let's call this first transaction, and this one called second transaction. So I want to make sure the transactions are set up properly. So the first one has to be the first transaction, and the last one has to be the second transaction. Okay, let's write this. So get transactions return value must be of type collection. So let's try and implement this. And I'm actually going to add a DD right here just to make sure we don't get to this part of the test once we get this running. I want to take it slow. So get transactions. This one's a tricky one. And that's why I say that writing this feature test first, or unit test, whatever you want to call them, they really help you think about how you want to build things. I know what I need here. I need all of the transactions related to that asset. So we can just say return. We have the account, and we can say we want the transactions with the asset, and then I want to get them. Now, the reason I said this was more complicated than I thought is because I've written this in the past, but I did it a little bit differently. And on this video, I wanted to keep things simple. But when I did it, I had to group them by account. And we're going to have to implement this as well later. We're going to have to group transactions by asset to make sure we don't have duplicated positions. And also that we don't waste computational power. But basically, I want to get transactions with asset, but I only want to get the transactions for this particular asset. So I can say transactions where asset IT, like this, we have the asset with the asset in get. So we can fetch the transaction. Let's try running this. Okay, we're getting to this DD. So we have the transactions. Let's run it. So average price is still not returning what we wanted. So how do we get the average price? Well, we need to figure out the total spend and then divide it by the quantity of asset units or whatever you want to call them, fractions. I don't know how to call this for crypto stuff. So we can say that the total spend was transactions, and we can say sum. So we have a transaction here. Whoops. And we can just say, if we go into the transaction model, you can see that we have this total invested method, which gets the amount you had on this transaction times the quantity. So if you spend $30 on 10 units, you have invested $300. So let's call this one. And then we have to get the quantity. This one's pretty simple. So the quantity is going to be transactions, and we're just going to sum the quantity. Since we're only talking about this specific asset, things are much easier. So transactions, and let's return total spend divided by quantity. So let's try this one. Let's run the test. Okay, cool. Now it's failing on the quantity expectation, which means this one is correct. We're getting what we want. So let's write down the quantity method, which returns a float as well. And the quantity is just transactions, the same thing we wrote earlier. Let's run it. Okay, now we are on. See how you get this really cool feedback loop. We were on line 59, now we're in 60, and now we are in 61. So let's go and write this one. Total spend. Cool. So total spend is going to also return a float, and total spend is transactions. We gotta sum them. So transaction. Oh, it's missing the FN here. And we can say transaction. Total invested. Same thing as up here. Let's run this test. Okay, now it's time for the total position, which is also fairly easy. Total position returns a float, and we can say this transactions sum, pass a closure, and say transaction total. This is a method of the transaction model as well. So if there's an asset, we get the current price for a given quantity, which is the amount that was present on the transaction. If there isn't, which means it was a cash transaction, we just multiply it. But you can see that this is pretty easy. So you don't have to care about this. I already had this implemented. But there's a way to fetch the total for that transaction. So if you spend, if you bought 10 shares of Apple at $10 and it's now 100, you spent $100, but now you have 1,000. This would be your total position. Now, let's run the test. So, total profit. Okay, let's write the total profit method. Returns a float, as you can expect. And it's going to be total position minus total spent. And there's a typo here. So, okay, now we get all the tests passed, including this piece of it. And it doesn't show you how many assertions you had, which I think is pretty cool because that's useless. But here we built this position class with it didn't just came out, right? We wrote the API we wanted on the tests. So this is the API we love to have. That's pretty much all I need for my app. That's how I would like things to be. This are the data I would like to see. And then we test drove it. So we wrote this after writing the test. And now that we got the tests passing and the tests are king in these situations, we can refactor it. So the first thing I would refactor is, let's see. So here we're calling quantity, and then we also have the quantity method. And we have the total spent here, but we also have the total spent method. So we could instead just say total spent divided by quantity. So let's go here. Let's see what else we can refactor. No, I think that's pretty much it. I think that was the method we could refactor. We could reuse it. Total spend, total position, quantity, average price. Yeah, I think that's pretty much it. I think this looks good. Are we using the asset? We're not really using the asset. Oh no, I think we are, because when we call total, we use the asset. So it's good to eager load this relation right here. So let's run it again. It's still passing. And now we have a really simple task that makes sure we can fetch a crypto position for a given account. Now, like I said, I could finish the video here, but I want to create an additional test. Remember I told you guys that people could have multiple assets, multiple transactions for multiple assets on a given account. I want to make sure that we can get the positions for all of these assets without duplicated positions. So what I'm going to do is I'm going to write another test. So let's call it services account service test. And let me copy this. So we don't need this. I think we won't need those. We can say test. It fetches the positions for all of the unique assets in an account. And we obviously need an account, so we can say an account. And I'm going to copy what we did on the previous test. And I'm going to add a Bitcoin, but I'm also going to add Ethereum. So a different asset, because we want to test multiple assets. And Ethereum costs $1,000. So we're adding some transactions. Since this is not what we are interested in exactly, I'm going to make this one line. Okay, that maybe doesn't look good because I have this extension, but this one looks. So let's make this the fuck? Why can't I make it a single line? Okay, I'm having some technical issues here. Okay, cool. So we have the first Bitcoin transaction. Let me rename this. And then we're going to add an Ethereum transaction. So we're going to say first Ethereum transaction. And we're going to pass Ethereum. And we paid $500 for it. And we bought 10 into Ethereum. So what I want to make sure is when I fetch the positions for this account, I want to make sure I have 2 positions only, even though we have 3 transactions. I want to make sure I have two positions. I want to make sure the Bitcoin position has a quantity of 3 Bitcoins. And I want to make sure the total invested is 90,000. So what we're going to do is let's say positions. And we're going to say new account service, even though this class doesn't exist yet. Fetch positions, and we're going to pass the account. Cool. And then we're going to say expect positions. First, I want the first position to be for its asset to be Bitcoin, and I want the account to be. We don't actually need to test the total invested, etc., because we have a test for this. I just got confused because when I wrote this previously, I only wrote a single test for this service. So, like I said, we also want to make sure we only have two positions here. So we want the positions count to be 2. We want to have 2 objects on this collection, not 3, even though we have 3 transactions. And then we want to expect the last of the positions. We want to expect its asset to be Ethereum. And we want to make sure the account is the same, like this. Now, you could refactor this using pass, and you could, instead of doing this, you could say and remove this, and like this. Basically, the AND method allows you to throw in another value on the chain. So right here, you're working with this value, and right here, you're working with this value. I use it, but not in this situation. I want to make sure they're properly separated, so you can see what we're working with. So if we run this test, account service and found. Let's create this class. Whoops, account service. Okay, we have the class already. Let's import it. Boom, let's run it. So undefine a method fetch positions. Let's write our method. We expect an account, and it's going to return a collection. Just your usual Eloquent collection, not an Eloquent collection, sorry, just your regular collection, which could be an Eloquent collection. So how do we implement this? We already know it's going to fail because we don't have anything there. So we should return a collection. We didn't return anything. So what we're going to do is, well, the first thing I can think of is that we need the transactions for the account. We want to make sure we have the asset. Actually not, because we fetch it on the position object. It doesn't really matter right now. So let's get it. And then I want to map it. So I want to map each transaction because there's no way I can fetch the assets. So I want to say transaction and return its asset like this. So if I do a dump and die right here and I run this test, you're going to see that we have Bitcoin, and we have Bitcoin, and we have Bitcoin, which is wrong. Oh, that's because it didn't change the names for Ethereum. If we run it again, you can see that we have Ethereum, then we have Bitcoin, then we have Bitcoin. And that's because I'm iterating through each transaction, and we have 3 transactions, 2 for Bitcoin and 1 for Ethereum. So we've mapped for the asset, which is what we want. So what we can do right now is we can map it to a position. So we can say return position, make. We already have the account, and we now have the asset. And why is this? Unexpected. Oh, sorry, short closures. If we run this now, you can see it fails on the quantity. And if we were to remove this line, since we're working with the first and the last object, always be aware of this when you're writing tests. This is a simplified example, and I cannot go through all of the steps. But since we're working with the first object and the last object of the collection, let's run it again. And you can see the test is passing. That's because this test is wrong, the code is wrong. We are returning 3 positions. But the first one is what we expected, and the last one is what we expected right now. If you wanted to make sure that you have the proper positions, without adding this line, you could make sure that you only have a single position for Bitcoin, and then you could make sure you only have 1 position for Ethereum. Since we're working with 2 assets, and I know for a fact that we should get 2 positions, that's fine. I could even go and say, okay, when I make sure this is correct, I could say that I want the array, I want the second element on the array, and that here I want the first element on the array. And if we run it, it's not going to pass because the second object of the array should be Ethereum, and it's not. It's Bitcoin. So I'm going to skip the syntax, and I'm going to go back and run it. Still failing. So here's an easy way to fix this. We can just say that we want unique objects, and now it's passing. So here's where the magic happens. Right now, we're mapping them for assets. Now, this is a collection of assets. And since we know the assets of each transaction and we
the position class itself does the job of figuring out the position for that given asset. We just need to make sure we have the correct amount of assets and that we don't have duplicates. So we can just say unique. That's pretty much it. We could actually go further and call unique after mapping it to a position, and that it would work. But the issue is it would be wasting computational power, because if you were to pass Bitcoin 10 times, you would have to calculate the position 10 times and then pick the uniques. If you do it before this happens, you're not wasting that computational power. You're only going to calculate it once. So if we go back to our account service test, we can fetch the positions for an account. And if we go back to the position test, we can fetch the position for a crypto asset for a given account. So this is pretty much how I build complex-ish features. I usually like to write tests first. Of course, once you get the hang of it, you start to do it naturally without tests. Maybe you write tests in the middle. But I really like to define my ideal API, like I said, the destination, and then build the road instead of building the road as you go until you get to the destination. The issue with this is you might not build the best road or the shortest road. You might be with something that works, but it's a road that takes longer to get to the destination, or, it's like the streets in Brazil, they're really bumpy and full of potholes, so they might not be the best. Writing the test first, you can build the API exactly how you want, because you already know what you want. You just have to build the road. So let me know what you guys thought about this video. I hope you enjoyed it, and I hope you guys learned something from it. And yeah, see you in the next video.